All right, let's get right into it. If you're prepping for your GCSE physics exams, you know required practical 9 can seem a bit daunting. But honestly, don't worry. Over the next few minutes, we're going to break it all down, boost your confidence, and show you exactly what you need to know to absolutely ace it. Ready? Let's go.
We're going to tackle this in 3 simple parts. First up, we'll nail the core physics concepts. Then, we'll pack your scientific skills toolkit. And to finish, we'll look at how you can apply all of that to a real exam question.
Right, part 1, the core physics. Before we even touch a ray box, we've got to get our heads around the 2 big ideas you're investigating here, reflection and refraction.
First, we have reflection. And really, it's as simple as it sounds. You know, like a tennis ball bouncing off of a wall. In physics, it's just when a wave, in our case, a light wave, hits a boundary, say a mirror, and it bounces right off. The keyword, remember here, is bounces.
And here is the one simple rule that's behind all of reflection. It's called the law of reflection. All it says is that the angle the light comes in at, that's the angle of incidence, is exactly the same as the angle it bounces off at, the angle of reflection. You've got to remember this. It is the golden rule for any reflection diagram you'll ever have to draw.
So that's reflection. Now let's look at its partner, refraction. This is what happens when light doesn't bounce off, but instead it passes through a boundary, like from the air into a glass block. When it crosses over, it actually bends, it changes direction. So here's the easy way to remember it. Reflection is bouncing, refraction is bending.
But why does it bend? Well, it all comes down to speed. See, light travels at a different speed in glass or water than it does in air. Imagine you're running on a nice smooth pavement, and you suddenly run into some really thick mud at an angle. What happens? You'd slow right down and kind of swerve, right? That is exactly what light is doing when it refracts.
Okay, let's switch gears. We've got the physics concepts sorted. Now let's talk about the skills that the examiner is really testing you on.
Now this is so important to get. The AQS spec is really clear that these required practicals, like number 9, are all about testing your working scientifically skills. They want to see that you can think like a scientist, not just that you can remember facts about light.
So this is your toolkit. These codes, by the way, are straight from the AQA specification. They're looking to see if you can plan an experiment, if you can make and record your observations accurately, if you can look at your data and see what it means, and crucially, if you can evaluate your own method for mistakes and then communicate your findings clearly. Trust me, these are the skills that bump you up into the top grades. And this is how those skills all fit together. You start with a hypothesis. For this practical, that could be I expect the angle of incidence to equal the angle of reflection. Then you plan your method. How are you going to use your ray box and protractor to test that idea? Your observations are the angles you actually measure. And finally, your conclusion is just answering the question, does my data back up the law of reflection?
All right, final section. Let's connect all this to what really matters, getting marks on that exam paper. How do we turn all this knowledge and all these skills into a brilliant answer?
You are very likely to see a question just like this. And I want you to notice that key command word, evaluate. This is a high-level question. It's testing your AO3 skills. It's not asking you to just define reflection. It's asking you to critique someone's experiment and say how you could make it better. So let's just break down what separates a weak answer from a strong one. A weak answer might say something really vague, like, they should have been more careful. A strong answer, on the other hand, uses proper scientific language. It talks about controlling variables, like keeping the width of the light ray the same. It discusses possible errors, like random errors when you're reading the protractor. And it suggests specific, justified improvements, like use a thinner slit for the ray box to create a less spread out ray, which improves the accuracy of the angle measurement. See the difference?
And if you need any more proof, here it is, word for word, straight out of the AQA specification. Assessment Objective 3 is all about this stuff, evaluating, making judgments, and improving methods. It's not a secret. They are literally telling you exactly what they want to see from you.
So the main takeaway here is this. The scientific skills toolkit we've just built for Practical 9, the planning, observing, interpreting, evaluating, that's not just for reflection and refraction. It is the key to every single required practical you have to do in your science GCSEs. If you can master it here, you'll be all set to master them all.